A solenoid of length 1 meter with 100 turns carries a current of 2 amp. Find out the magnetic field created by this current at the point well inside the solenoid. And part B, if the number of turns is decreased to 50, what effect would that have on the magnetic field strength? So we need to find out the magnetic field strength of a solenoid. In order to find it, we need to use the formula B equals to mu naught times N times I divided by L. B is the magnetic field strength in terms of Tesla. Mu naught is 4 pi times 10 to the power of negative 7. That's the constant. N is number of turns, capital N. I is electric current in terms of amps. And L is the length of solenoid. So we're going to have 4 pi times 10 to the power of negative 7 times 100 times 2 divided by length, which is 1. So therefore, we can calculate it. 2 times 100 times 4 times 3.14 times 10 to the power of negative 7. That will be 2.5 times 10 to the power of negative 4 Tesla. Now on the second part, it says if we decrease the number of turns from 100 to 50, it means that we make it half. What happens to the magnetic field strength? We have two different ways to do that. One of them is just write the formula again, make it 50 for N and write it again. But the simpler way is 50 is half of 100. It means that when N becomes half, B becomes half as well. So we just, for the part B is gonna be 2.5 times 10 to the power of negative 4 divided by 2, which will be 1.25 times 10 to the power of negative 4 Tesla. This is much easier in order to find the answer to the part B. So that's how we calculate the magnetic field strength of a solenoid.